And we're back. That did not record it, whatever you just
Okay,
said.
good.
That conversation was not. Lucky for you, I think. All right. So here's what I would like to do today. First things first is I was nice to you guys. I looked back and I found this. This is the differentiation rules. Okay. Now you know this first box up here and then the third box. You don't know what a chain rule is yet. That's section 3.4. And don't even worry about the inverse of trigonometric functions or the logarithmic functions. Okay? We'll get there. But this is something that you should keep. Okay? I put 3 holes in it so that you could put it in a binder if you'd like to. But you should definitely keep this paper. You should. If you need an extra copy, I'll post it on Canvas too. There you go. 1, 2, 3. There you go. But again, look at those inverse trig derivatives. Whoa, those look fun. Actually, you know what's funny? Somebody emailed me. If you know Dylan Walls emailed me about 3 weeks ago and said, hey, one thing that you should tell your calc students is you should make them memorize the inverse trig derivatives. And he said, because it's expected that we know them right now. And he goes, and I am struggling. And that was in all caps. So I don't know if I'm actually going to do that. I think that's really like a professor to a professor thing. Like, I don't know if all professors would make you memorize all of these things. I think it's just kind of like on a person-to-person basis. And my person says, no, you don't need to memorize those. All right. Now, the other thing that I did was I did make a review sheet for you guys. Oh. Now, I don't have the key. I don't have a key because I literally just threw this together a little bit ago. Okay. So I would like to do these in class today. Does that sound good? Now, some of them look a lot like your homework problems. That's planned. There you go. This is, I call this quiz Derivatives 2.0 because we already did the first derivatives quiz. We already had a quiz just over derivatives. That was last chapter when we didn't know the rules. So this is Derivatives 2.0. Now that we know some of the rules, okay, now that we're accumulating our list of derivative rules, okay? So let's just start with number 1. Number 1 being the whole function. Okay? Find the derivative. Y equals 2x minus 1 over 3x plus 4. Is do send to a new page. All right. Come on. There we go. Find the derivative. What is this implying that we need to do? The quotient rule. Right. See, I don't say use the quotient rule to find the derivative, or use the product rule to find the derivative, or as when we get to it, the chain rule. Use the chain rule to find the derivative. You have to instinctively know that you should be using that. Now, how do we know that? Well, I see a fraction. That's plain and simple there. I see a fraction. If you see a fraction, you should either try to reduce it some way to get to a polynomial, or just use the quotient rule. Like this one, like I can't take 2x over 3x plus 4 and 1 over 3x plus 4 and make it any easier. What am I talking about here? I'm talking about if I had something like this, x to the 4th plus x to the 3rd minus x squared, all divided by x to the 2nd. I don't know. I would not want to use quotient rule on that. That would make that problem a lot harder than it needs to be. What I can do is just give that denominator to each part, because I think you guys can see that those will all reduce nicely, right? just subtract them all, and then use our polynomial rule. Use our, finding the derivative, knock it down, bring it out in front, knock it down one. But obviously we can't do that here. So let's use our quotient rule. Now the quotient rule is, now I screen captured for this, the differentiation formulas, I screen captured what the book gives, and they write it a little bit different than I do. I say f prime g minus g prime f. They say g f prime minus f g prime, whatever, same thing. Okay. I'm going to put that right there because I will use that for like the next 3 weeks. Okay, so y is equal to 2x minus 1 over 3x plus 4. Here is my f. Here is my g. And I say the quotient rule is f prime g minus g prime f all over g squared. Let's do it. F prime. What is the derivative of the numerator? Just 2. Right, just 2. The derivative of 2x minus 1 is just 2. Okay, so that is 2 times 3x plus 4. Oh, that's a 3x plus 4. Come on now. 3x plus 4. Minus g prime f. What's the derivative of the denominator? Just a 3, right? Because the derivative of 3x is just 3. The derivative of 4 goes away. The derivative of constant is 0. So this is 3 times 2x minus 1. All divided by 3x plus 4 squared. Now, again, if you want to FOIL that out on the bottom, more power to you. I don't need you to do that, though. Okay, let's manipulate the numerator, though. Let's algebraically reduce down 6x plus 8 minus 6x plus 3. Okay, cool. Over 3x plus 4 squared. So that gets me 11 over 3x plus 4 squared. Nothing to reduce from there. So I get to, if you wanted to make it a little bit harder, yeah, just go ahead. Or like denominator. 9x squared plus 24x plus 16. That's quick math. Questions about that one? All right, let's take a look at the next one. Come on, come back to me. So this is problem number 2. Ooh, cosecant plus cotangent. Cosecant plus cotangent. Yikes. Cosecant plus cotangent. Now, the plus in there, do I need to do any like sort of rule because there's an addition sign in there? No. I can just find the derivative of the parts, right? This is not a product, it's not a quotient, there's any I can just, there's no, like the sum rule is just finding the derivative of both parts. Find the derivative of the first and the derivative of the second. So that's all I'm going to do. I'm going to find the derivative of cosecant x. Okay, derivative of cosecant. Now, try to remember. The cos always have the negatives, right? So it's going to be negative, and they include themselves. So is it, I think it's cosecant squared tangent, I think. Cosecant cotangent, and not even squared. Ugh. That's right, the squareds go with the tangents. Duh. Okay. Cosecant cotangent. Cosecant cotangent. Plus, okay, the derivative of cotangent squared. So again, the cos always have the negatives, and this one is negative cosecant squared. Okay, so first thing I'm going to do is just, I should have probably done this already, cotangent minus cosecant squared x. And now what I'm going to do is I'm going to factor out the cosecant. I think. Let's try that. Well, yeah, let's try. Let's factor out a negative cosecant times cotangent x minus cosecant. Ooh, cosecant x. Can I do anything with that? Is there any trig identity that has cotangent and cosecant with it? Yeah, no regulars, just the squares, right? So I'm good, I think. So I would like you to do that, but that got to be honest, that's still simple too, though. No plus. Sorry, factor on a negative, turn positive. Sorry. Do a lot of complicated math, but then when it comes to factoring out a negative, always forget. The one thing why I was questioning myself, because the one thing that I thought I may have been able to reduce down right away was this piece in here, cosecant x, cotangent x. Because cosecant is 1 over sine, right? Because cosecant is 1 over sine. And that would have been 1 over sine x times cotangent. Cotangent is cosine over sine. You should always check when I'm multiplying those things with the tangent, because maybe, just maybe, you'd be able to reduce it down. But this one, I'm going to end up getting cosine over sine squared. And that's not going to do anything for me. Okay. What I mean by that is if I had gotten, I might be getting ahead of myself. I might have put one like that in there. Let's take a look at number 3, because that might happen in number 3. And if it doesn't, I'll explain it after doing number 3. Find the derivative of y equals cosine x plus tangent x. Okay, what is the derivative of cosine? Negative sine. Plus, what's the derivative of tangent? Secant squared. Can I do it? Is that it? Is that really it? I think that's it. I think that's all there is. That's a nice and easy one, isn't it? You could say secant squared minus sine. Sure, just flip around. I think that's about it. Okay, so what was I talking about earlier? I was talking about if I had done something like this. Change colors. Emphasize that I'm doing something different. What did I checked secant cotangent, right? Or no, cosecant cotangent. If maybe you had had secant x cotangent x, right? Secant x cotangent x. Maybe you were going to leave that as an answer. Remember that secant is 1 over cosine, right? Secant is 1 over cosine. And cotangent is cosine over sine. You see how I can reduce that? You see how I can say, so this would be 1 over sine x, which is technically what? Cosecant, right? 1 over sine is cosecant. Okay. So watch out for those instances where you may be able to cancel out a sine or a cosine somewhere with tangent. You know, thinking about it back here, if this had been cosecant tangent x instead of cosecant cotangent, if this had been cosecant tangent x, well then that would have changed that. So cosecant tangent x, that would have been 1 over sine x, and then times sine x over cosine x, which would have canceled. Then we could have done that. So it would have been 1 over cosine x, which is secant x. Right? Always watch out for those. Okay, but we didn't have that, so. I'm not saying that the one on the quiz won't be like that. Like, will be exactly like these. I just was throwing them in there just to see what it was like. Okay, So y equals sine x over 1 plus sine x. Sine x over 1 plus sine x. Okay, what do I have to use here? Quotient rule. I've got to use the quotient rule, right? So that would mean, again, f prime g minus g prime f all over g squared, where this is f and this is g. I try to stay away from giving you f of x is equal to on the quizzes. And I try to make them all y is equal to. All right, f prime g. What's the derivative of sine? Cosine, regular cosine. Derivative of cosine is negative sine. I don't know why. I always think about it this way. Going from sine to cosine is like, I don't know, I always felt like we learned sine first, right? So sine to cosine, or sorry, derivative of sine is just cosine. But if I work backward, if I go cosine first, I've got a good negative sign. I don't know why. Again, weird things that make sense in my head. Okay, so derivative of sine is cosine x times 1 plus sine x. And then minus, okay, now we have the derivative of the denominator. 1 plus sine x. Well, what happens with my 1? Goes away. Then we have cosine times sine, all divided by 1 plus sine x. Just testing. Make sure you get g squared. All right, now, the reason I was hesitating on that because now I see what I can do in the numerator. I do not want to distribute in my cosine. I actually want to factor it out. I want to factor out my cosine. I want to get it all out of the both terms. And when I say both terms, I'm meaning these two big terms have a cosine in them, multiplied in with them. So that means I've got a cosine x times 1 plus sine x minus sine x divided by 1 plus sine x squared. And I think we can see that the sine x's are going to cancel. So that's a cosine x times 1, or in other words, cosine x over 1 plus sine x quantity squared. And I think that's the way we have to leave that. Again, if you wanted to FOIL that 1 plus sine x, go for it, but you don't need to. All right, let's take a look at the next one. So that was my fraction. Find the derivative here. Honestly, I think we could do this two different ways. I could either multiply first, then find the derivative, or find the derivative first, then reduce it down. Either way is fine. Let's show both ways, and then you guys can decide which one you'd like to do. Let's find the derivative first off. Now, if I want to find the derivative, I have to use product rule, right? My computer's in the back. If I want to find the derivative, I've got to use product rule. Remember, product rule is f prime g plus g prime f. It's the plus. So let's find f prime. Remember, f being this and g being this. F prime. What is f prime? 8x. Just think about that moment right there. That moment right there where I just said, what's the derivative of 4x squared minus 3? If we were doing the derivatives 1.0 quiz, oh my gosh, that alone would have taken us like 10 minutes. Okay, 8x. And then f prime, then g. 8x plus 1. Okay, g prime, f. What's g prime? Just 8. Just think about that. No, I won't do that again. Okay, and then it's 4x squared minus 3. Okay, all divided. Oh no, that's not quotient rule. This is product rule. Whoop. Okay, now I multiply in. So 64x squared plus 8x, and then plus 32x squared minus 24. Okay, that means it's 96x squared plus 8x minus 24. That's y prime. So that's finding the derivative first. Whoa, where'd you go? Where'd you go? There it is. Okay. Make you a little bit smaller. Move you over a little bit. All right. Now I'm going to find the derivative second. I'm actually going to multiply first, then find the derivative. What do I mean by that? Well, y in its original form is 4x squared minus 3, 8x plus 1. So when I go to FOIL it, that's going to be first 32x to the third plus 4x squared minus 24x minus 3. But that minus 3 is not going to matter. So now, since that's y, let's find y prime. See, I no longer need to use any product rule because I've already done I've got the product out of it. And I've already multiplied. So now when I go to find y prime, that's 3 times 32 is 96. 4 times 2 is 8. Minus 24, 3 goes bye-bye. Same answer, either way. You can pick. I don't know, in my opinion, it wasn't too bad either way. What's that?
Like, when are you like allowed to do that?
When it's polynomial times polynomial.
That's the only time.
Right. If I had done, like, to get the product rule out of it, like, I cannot do that. When did we do the product rule earlier? Did we do it here? No. Here? No. Here? No. Like, if I had something like this, like x squared plus 4 sine x. That's not going to do anything if I multiply it in. I'm still going to have to use the product rule anyway. You know what I mean?
Yeah.
So I'm stuck. I've got to use the product rule at some point.
What if it's like a square root of x? Or like...
That would still be okay. Like if I took this as the square root of x, how would I work with that then? Well, that would be x squared plus 4 times x to the 1/2, right? Remember, you always want to turn ones that are powers of x that are in the denominator into a negative exponent and work with it. And you also want to turn any radicals into a fractional power and then work with it. Because now I can distribute that in and say like, okay, 2 plus 1/2 would be 2.5. So 5x to the 5/2 plus 4x to the 1/2. Then I can find the derivative of that if I wanted to. The other way around it would do f prime g f prime g plus g prime f. Either way is fine. Does that make sense? That answer your question? Okay, let's take a look at, which one did we do? We just did 5, let's do 6. Oh, there's a second part. This is all like just the suppose. Evaluate these things. Come on, buddy. It's gonna be okay. It's only Tuesday. We've got a long week ahead of us, buddy. Okay, thank you. You just gotta talk nice to the technology sometimes. You know, people don't realize this, but technology, like, it has feelings. It's got a soul. Okay, you just gotta talk nice to the computers, and they'll work better for you. That's Jen, yes, right there. Okay. That's the next generation. Oh, Jen.
Next
Jen squared. Yes.
Might we correct the computer?
Just say it's all right, buddy. We got this. We can do this. All right. So suppose that u and v are differentiable functions of x at x equal 5. So we're saying so that u and v are just kind of like two different functions. I could call them f and g. I could call them h and j. I could call them whatever I want to do, k and l, whatever. I'm just saying that u and v are differentiable functions at x equals 5, such that u of 4 is 2, v of 4 is 4, u prime of 4 is -1, and v prime of 4 is 6. Okay, none of that means anything right now. I'm just giving you a set of rules, or not a set of rules, but a set of, a description of u and v at certain places. This is the part about, this is telling us what to do here. What is this d over dx of this thing telling us? Find the derivative of that, right? That statement right there is saying, find the derivative of this thing, okay? D over dx of 3uv minus 4v, okay? Let's find the derivative of that and then see if this can help us, okay? So finding the derivative of 3uv minus 4v, d over dx of 3uv minus 4v. Okay, what do I have to use right there? What am I doing with u and v? I'm multiplying them together, aren't I? What does that tell me I have to use? Product rule. I've got to use product rule here. So this is going to be, in u's and v's, this is going to be 3, and honestly, that 3 is a constant, isn't it? 3 u prime v, and I've got to make my v's really pointy, so they don't turn into u's. 3 u prime v plus v prime u. Right? Then minus 4 v prime. Why doesn't that 4 go away next to the v prime?
Because it's being multiplied to the v.
Good. It's being multiplied to the v and not added to it or something. If it was added to it, then it would go away. But since it's a constant multiplied, I can keep it there. All right, well, let's just distribute in the 3. 3u, oh, come on, keep it rounded at the bottom there. 3u prime v plus 3v prime u minus 4v prime. Okay, this all looks like gibberish right now. But now I can use the fact that I want to find this at x equal 4. Right? So this is technically now 3u prime of 4 times v of 4 plus 3 times v prime of 4 times u of 4 minus 4 v prime of 4. All I'm going to do here is plug 4 into each of those things. The nice part about it is that the premise of this problem told us what each of those things are. Okay, so this is 3 times, what is u prime of 4? -1. What is v of 4? 4. Plus 3 times, what is v prime of 4? 6. Times u of 4, 2, minus 4 times v prime of 4, which gets us a 6 again. Okay, now I just got numbers. So that would be -12 plus 36, so 24 minus 0? Does this really all equal 0? Well, that would be cool. This is, what's that? 3? 3 times -1 times 4 plus 3 times, come on now, plus, where'd you go, plus? Plus 3 times 6 times 2 minus 4 times 6. 0, that's pretty cool. Equals 0. Okay. Let's do the other version of this, or the other evaluate of this. Okay, this one's a lot simpler because I just say evaluate u over v. Quotient rule. Evaluate the quotient rule at 4, which is u prime v plus, no, minus v prime u over v squared. Regular v squared on the bottom. Not the derivative, just regular v squared. All right, so again, this is like saying u prime at 4 times v of 4 minus v prime of 4 times u of 4 over v of 4 squared. I'm not going to go ahead and write that like I did in this product rule, because I hope we understand that now. What is u prime of 4? Negative 1. What is v of 4? 4. Minus v prime of 4. 6 times u of 4. 2. All divided by v of 4. 4 squared. Okay, so this is negative 4 minus 12, so negative 16. Hey, negative 16 over 16. That reduces all the way down to negative 1. Questions about that? A lot of that question is understanding the notation, right? First off, you got to understand the notation that's telling you to find the derivative. And then you got to understand that, well, in this case, I'm got to use a product rule along with, just finding the derivative. And then once you get to this point, you got to understand that all of this at 4 means you just got to plug in these values at 4 and figure it out, numerically figure it out in the end. Okay. Let's keep going. We've got 12 minutes left. We can do a couple more. We're on 7. There we go. Okay. What am I going to do with those last 2 terms? My first 2 terms are good, but my last 2 terms, I got to turn those into like just powers of x, right? I just have to turn those into powers of x. So y is equal to 4x to the negative third plus 2x minus 3x to the negative fifth plus 6x to the negative 1/2. Notice how the square root turned into a square root of x to the 1/2, and then since it was in the denominator, it's negative 1/2. Okay, let's find some derivatives. Negative 12x to the negative 4th plus 2, just straight up 2, plus 15x to the negative 6th. Be careful there, don't bring it to negative 4. Right? You're not going towards 0. You're not going up. You're going down. Right? Kick it down the power, x minus 1 in the power. Plus, okay, minus, this is going to be minus. 6 times negative 1/2 is negative 3. X to the, negative 1/2 down 1 unit would be negative 3/2. And then we'll just put, I like to clear out any negative exponents. And that's really all the simplification that you would need to do. So negative 12 over x to the 4th plus 2 plus 15 over x to the 6th minus 3 over the cube root, index over power, power over index, the square root of x to the 3rd. And I'm okay with leaving it like that. Again, our Algebra 2 brain probably tells us to rationalize the denominator down here, but we're leaving that go. Okay, let's keep going. Find the first and second derivatives of these things. Find the first and second derivative. Ooh, this is fun. Okay, y prime. What do I have to use? Product rule, right? Got to use product rule. F prime g, so this is f and this is g. F prime g plus g prime f. 8x to the 7th times e to the x plus, okay, g prime f. What's the derivative of e to the x? E to the x. X to the 8. I can do something to make this problem easier. I can take out the e to the x. So e to the x comes all the way out front and makes this 8x to the 7th plus x to the 8th. You could reorder that and say x to the 8th plus 8x to the 7th. That's fine too. So that's y prime. And if I want y double prime, oops, that is y prime. If I want y double prime, I'm just going to use the product rule again. Okay, so I'll make my f now as e to the x, and this is g. So f prime g, e to the x times the original, 8x to the 7th plus x to the 8th, plus g prime, 56x to the 6th plus 8x to the 7th. And then just a little pulling out of that e to the x again. E to the x comes all the way out in front. That gives us an 8x to the 7th plus x to the 8th plus 56x to the 6th plus 8x to the 7th. So we got two of those 8x to the 7th. So just reducing it down, e to the x quantity, I'll put it in standard form too. X to the 8th plus 16x to the 7th plus 56x to the 6th. There's y double prime. Y single prime, y double prime. That was fun. I like that one. Cool, pulling out of the EDX. We did that in one of those notes problems that we did. Keep going down. Don't do that. Okay. Got some acceleration and velocity going on. Particle moves along a line so that its position at any time is given by that equation. Find the velocity acceleration functions. How do I find velocity? How do I find velocity? I throw something and see how fast it goes. I find the derivative of position, right? S prime of t is equivalent to v of t, which in our purposes here is 4t to the third minus 6t squared plus 2t minus 1. And then I say, well, if I want acceleration, S double prime, which is v prime, is acceleration. Instantaneous acceleration. 12t squared minus 12t plus 2. And then it says find the acceleration after 1 second. So it'd be 12 minus 12 plus 2, so 2 meters. So we say meters? Meters in seconds, meters per second squared. Plug it in 1 for acceleration. And again, I hope we understand like the power that we just said there. Like all we had was a position function and we found instantaneous acceleration. Instantaneous acceleration. And so at any given moment, how fast is the particle accelerating? Like getting faster by a rate of 2 meters per second squared. The last problem here talks about finding an equation of the tangent line and normal line. I should do this one. Because that looks funky because it's got a trig function in it. What's the come on now. Where'd you go? Hello? McFly. Okay, there it is. Find an equation of the tangent line and normal line of y is equal to 3 tangent x. What's derivative of tangent? Secant squared. So y prime is equal to 3 secant squared x. Okay. 3 secant squared x. That's equivalent to the slope, right? So this is going to be, if I want 3 secant squared x, I want to find when x is pi over 2. So that's 3 times secant squared of pi over 2. That's going to give me my slope of my line. Okay, so that means I've got to take this. Ooh, secant squared. What is secant again? 1 over cosine? Cosine of pi over 2 and all of that squared. That's what secant squared really means, right? What is cosine of pi over 2? What is cosine of pi over 2? What's the x value of pi over 2? $90 degrees, right? What's the x value at 90 degrees? You just got this. 0! That took way too long. That took way too long. What happens here? What happens there? It's undefined. Undefined. The tangent line is undefined. The tangent line is undefined. I'm thinking here that it probably didn't mean to be undefined. Like I made this problem and I did not mean for it to be undefined. But I might be prepared to find tangent and normal line. Remember, tangent line, you just find, so say this came out to be like 1 instead of undefined, right? Say this came out to be 1. Then you would use the slope and that point. Now, did it give us the full coordinate? No, it only gave us the x value. How would I find the y value? Plugging it back into the original, right? So tangent at pi over 2, we can figure that out. Multiply by 3, that's my y value. And then you use your y minus this is equal to m x minus pi over 2. How would I find normal line? What is normal line? That's tangent line. What is normal line? Opposite reciprocal slope. It's the perpendicular line to the tangent line. So say if I had some function and I found the tangent line, the normal line is the perpendicular to it, right? So whatever the slope may come out to be, I've got to take the perpendicular slope at that same point and use that. Hold on just one second. Any questions on that one? That's kind of a weird one.
That was weird.
Yeah. Oh, you just need a copy. Man, that was
No, that's just me though.
perfect time. Yeah, time flies when you're having fun.
Gotta go for
That one's better.
from 3 in a row. Yeah, same.
So I can work in my room.
I need to get that done next year.
If anybody has any questions, I usually get here like 7 o'clock in the morning.
Mr. Leverett, I might be coming in a few minutes late tomorrow, but then I have mentoring afterwards, so I can just like.
Okay.
Juan, where's the call again?
I came all the way out here too.
Yeah.
Mr. Robert, thank you for making a review.
You're welcome.